CASA. Who are the most loyal restaurant customers? A local restaurant collected data to better understand which factors predict how often consumers visit in a year. The data set includes customer satisfaction on a 10-point scale, preferred time of day to visit, lunch or dinner, preferred area to eat, bodega or restaurant, and total number of visits in the past year, which is how we're going to code customer loyalty, which is what's being predicted, right? How many times you're going to visit based on the other things. Conduct the appropriate hypothesis test to determine which variables can be used to predict customer loyalty using alpha of 0.05. You would need to use binary encoding for the variables time of day and area of restaurant. Code lunch is 0 for time of day, and restaurant is 1 for area of restaurant, and 0 for bodega. Okay, so let's go over to the data and zoom in again. Try to remember to get that zoomed by the time I give it to you. Alright, so what's being predicted is loyalty, which is number of visits per year, based on satisfaction, when they eat, lunch or dinner, and if they eat in the bodega or the restaurant portion of the restaurant. Okay, so data analysis, regression, the Y variable is loyalty. Oh shoot, I gotta stop. Let me cancel. I didn't do any of the coding. Alright, so I've got 2 qualitative variables. Both of those need to be coded. So I'm going to insert 2 columns. I'm going to highlight 2 columns and pick insert. That'll insert them both at the same time. This one is the meal, and this one is the location. And I've got to get the coding right. So for the meal, let me go back. So the meal, lunch is 0. And for the location, restaurant is 1. So let's do that. So for the meal, lunch is 0. So equals if the meal is equal to lunch, then it's a 0, otherwise it's 1 if it's dinner. And for the location equals if that is equal to restaurant, then it's a 1, otherwise a 0. I think I got that right. Let me double check. 1 for restaurant, yeah. 0 for bodega. Okay, so we're all coded. Now we can run the data analysis toolpack. So Y goes down, all the way down. Get all the data. And then X is just the quantitative. Leave off the qualitative stuff that was recoded. Labels, confidence interval 95%, and then the output range, click here, and pick up here. And while still highlighted, come over here, pick numeric. Let's see if we get lucky. Everybody, yes, everybody's a winner, except for the intercept, which, remember, it's the one where we don't care if the p-value shows up as non-significant. Everybody else was significant. So that's still highlighted. Copy it. Paste there. And now we can start. So the intercept coefficient p-value, satisfaction, coefficient, and p-value, meal, coefficient, and p-value, location, coefficient, and p-value, standard error. Alright, so predicted loyalty, which is what we're predicting, is equal to coefficient locked plus satisfaction locked times satisfaction in our test data plus meal locked times meal in our test data plus location locked times location in our test data. Copy that down. Remember, this row will show the intercept value because all these are zeros, so nothing's filled out. Then equals this minus 2 times standard error, which is locked. Copy that down. And then the prediction plus 2 times standard error, which is locked. Copy that down. And let's answer the questions. Interpret the coefficient for location. Alright, so 1 is a restaurant. So, in other words, if it's a restaurant, then satisfaction goes up 1.09. Meaning you get an additional 1.09 visits if the customer went to the restaurant. That inspires more loyalty than the bodega. So restaurant diners visit 1.09 more times per year than bodega customers. All things being equal, that's B. For meal, okay, it's 1.39, so if it's dinner, it inspires more loyalty. So dinner customers visit 1.39 more times per year than lunch customers. That's A. Which variables are in the final model? Well, all 3. Satisfaction, meal, and location. And interpretation coefficient for satisfaction, which was a 0.71. So each 1 point increase in satisfaction adds 0.71 annual visits, holding all other variables constant. Alright, for a customer satisfaction score of 9, okay, so now we're going to fill this in. Satisfaction score of 9, who eats dinner, so dinner is a 1. The bodega is a 0. So we predict that person's going to visit 8.32 times. Which predictor had the strongest effect on customer loyalty? So what's the biggest coefficient up here? It's eating dinner. So B. And interpret the intercept. And it would be C. So it's satisfaction is 0, and then lunch is a 0, and bodega is a 0. So where everything's a 0, that's C. And what's the standard error represent? The typical distance actual visits fall from predicted visits. And we're all done.